Hello everyone, I'm Mayank Gupta and today I'll be teaching you the basics of Matlab. Whatever I teach in this video lecture will be considered final for the uh, computational engineering test, which has to be held on 16th of April by Dr. Devas. So in this lecture I'll teach you how to do basic arithmetic operations on numbers, vectors and on matrices. Then I'll teach you how to um, make functions in Matlab, and I'll give you example of bisection function and Newton-Rhapson methods function. And then we'll jump to how to do uh, linear regression in R, first through the programming interface. Oh, I'm sorry, through Matlab, and first through the programming interface and then through the curve fitting toolbox which is available in the Matlab. Okay, so let's get started. First, let's see how to do basic arithmetic operations. So if you want to calculate to add, to divide, to multiply and to subtract, you just need to type in the expression and you'll get the answer. For example, if I type 2 plus 3, I'll get the answer. Then 2 minus 3, similarly. Then similarly I can multiply the numbers using the star operator, and then I can divide using the backslash operator. Okay, so this is how you do basic arithmetics using on numbers using these four operators. Then next thing to do is, if suppose you want to store your answer in some variable, then you can just do it by typing in the name of the variable in which you want to store it. For example, I want to store the answer of 2 into 3 into a number into a variable called x, so I can just type in x equal to 2 star 3, and I'll get the answer, and that value will be stored in x. So one thing you'll notice that here in the workspace you'll see two variables, one is the answer and the other one is x. So the answer variable is an inbuilt variable which stores the value of an expression if there is no variable explicitly defined for the expression. For example, in this case we didn't define any variable, we just wrote 2 divided by 3. So this expression will be evaluated and the value will be stored in this ans variable. Okay, and it will keep on updating if you don't specify the variable. Suppose if I type uh, 2 to the power 3, this cap operator here is used to denote the power, so it's the written expression is 2 to the power 3, and if I multiply it, the answer now has changed to variable 8, to the value 8, which was earlier 0.667. Okay, so it has been changed from this to this, because this is because we didn't explicitly define any variable here. So if I want to store this value in y, I'll just type in y equal to 2 to the power 3, and here I'll get y, and this workspace will be updated with the new variable. Okay, so this is how you define new variables and store different values. You can just type in a whole expression. Now suppose I want to get x square z equal to x square plus y square, I can just type in and then z will be evaluated. So this is how you define variables. Now we'll see how to define vectors. So vector is nothing but 1 by n matrix. It's just a list of numbers. You just need to put in the numbers and you'll get a vector. So to define a vector, suppose you define vector a equal to, for defining a vector you'll type square brackets, and in this you'll put in the values that are separated either by a space or by a comma. You can use both are equivalent in this case. So suppose if I want to get a vector of first 5 natural numbers, so I'll type in 1 space 2 space 3 space 4 space 5, and I'm just pressing enter. So I'll get a vector of 5 numbers. And similarly, if you replace everything with the comma, then it doesn't matter, I will get the same vector. So you'll see it. Okay, So this is how you define a vector. This is basically a row vector or a row matrix, you can say that. Similarly, you can define another vector. Suppose I say 1 oh, sorry 6 comma 7 comma 8 comma 9 comma space 10, sorry, and I'll get another vector. Now I can do basic arithmetic operations on these vectors. So if I type a plus b, I'll get the element wise addition. That means that the first element of a will be added to the first element of b, and the answer will be stored in the answer figure, obviously. So similarly, 2 is added to 7 to get 9, and the list goes on. Okay, similarly I can type a minus b and I'll get the answer, it's whole minus 5. Now if you do a star b, that means if you want to multiply these vectors, you'll get an error. This is inner matrix dimension must agree. That means if the first matrix is m1 is to n1 and second is m1 m2 is to n2, then n1 should be equal to m2. But in this case it's both 1 into 5 matrix. So 1 into 5 matrix multiplied by 1 into 5 matrix will give you an error. It's basic matrix algebra. So if you want to multiply the first element of a with first element of b and the second element of a with the second element of b, for that you need to use the dot operator. The dot operator specifies that the operation that is to be followed is an element wise operation. So if I type star b, then it will, that basically means that the numbers of a will be element wise multiplied by the number of numbers with b in b. So this is how this, you won't get an error. Similarly, you can divide uh, by element wise. So if I type a dot slash b, then you'll get the element wise division also. So this one thing you need to keep in mind for element wise operation. The same is applied for a matrix. So if I type in uh, a matrix, suppose, and to define a matrix, the same square brackets will be used. The only difference would be to shift to the other row, you need to use a semicolon instead of a comma or space. For example, I want a 3 by 3 matrix of number 1 to 9, so I'll type 1 space 2 space 3. Now to shift to the next row, I'll type in semicolon, then I'll type the numbers again, 4 5 and 6, and then to next row, that is 7 8 and 9. So now you see I got a new matrix P, which is a square matrix, 3 by 3 square matrix, and the numbers I've defined in that way. And similarly I define a new matrix, that is all one space 1 space 1 semicolon 1 space 1 space 1 and semicolon 1 space 1 space 1. So now we have two matrices P and Q. So say the same thing, P plus Q, that will add the matrices. So P plus Q is same as P dot plus Q, because all the elements are added, all the subsequent elements are added. So it's similar as P dot plus Q, so you don't need to explicitly define it. Similarly I can type P minus Q. Now since these both are 3 by 3 matrix, we can actually multiply the matrices also, so we'll just need to type P star Q. So this is the matrix multiplication, not the element wise multiplication, because that will follow the matrix algebra rule. So if you want to multiply by element wise, you'll need to use the dot operator, and you'll see the answers are different. So that is the this P star Q denotes the actual matrix multiplication, not the element wise multiplication. So this one thing you need to keep in mind, how to do matrix multiplication. I generally don't do division in matrices, so we'll skip that portion. But I'll tell you, there are left in Matlab you have left division and right division, but we don't need to study that thing. It's basically if you write a P left division of Q, it will do P into inverse of Q. So to so we'll skip that portion. We don't need to use that here because we generally don't do that. Um, and similarly you can do now. Okay, suppose now you want to other operations on a matrix include the transpose operation. So you type in, for doing the transpose, you type in the matrix name, and you'll use this inverted comma, single inverted comma, p, it's like p dash, and you'll press enter, and you'll find that it found an inverse. Earlier it was 1 2 3 4 5 6 and 7 8 9, so it has been transposed. Similarly, you can find the inverse of the matrix. You just need to type in, and you'll type in the matrix, suppose P. So here is it. And okay, so this particular thing, it says that every element would be multiplied by this thing. So, and it gives a warning that matrix is close to singular or badly scaled. That particularly means that if you find the that matrix singular means the mod is 0. So the determinant of this matrix is close to 0, maybe possibility is 0. So let's check it. It's 0. You type in det and you'll type p, and you'll get determinant that is 0. So this matrix is non-invertible, but what Matlab does is it uh, scales the value so that an inverse can be found. So when if you get a warning like this, then that inverse is not the true inverse, it's pseudo inverse of that particular matrix. So so we learned a new command, that is det command, to get the determinant of any matrix. And similarly in P, that gives the inverse of the matrix, and the dash one which gives the transpose of the matrix. Okay, so this is the basic matrix operation in this one. Now we'll see how to do some basic statistics operation, for example mean, standard deviation and everything. In Matlab I'll tell you some inbuilt functions, and only those needs to be considered. Okay, so let's start by defining we defined a vector A earlier, so let's see what A was. A was this num, it's basically a list of all the numbers. So uh, let's see what can we do with this list. So if you want to find the mean value of all these numbers or any other list, you just need to type mean, and then pass it in the function, you pass it the values. Suppose I pass in the vector A and press it, I'll get the mean value. So you can just find out if it's correct. Okay, so and if you pass suppose a matrix, then matrix, suppose we defined P earlier. So you pass in P, you'll find that three different means have come. This basically means that the mean values have been calculated column wise. So the first column had mean 4, the second column had mean 5, and the third column has mean 6. Okay, so this basically happens because when you do data analysis, you have a n by m by n matrix in which the n are different variables, and the m values tell you the number of observations. So you generally need to find the mean values of a particular variable. So this is why this gives a column wise uh, mean. Similarly, to uh, find the standard deviation, you have an inbuilt function called std, and you can just type in the, suppose I type vector A, I'll get the standard deviation of A, the values in A. Okay. Similarly, you want to calculate uh, variance is standard deviation square. So std of A, and you'll square it to get the variance. So variance is 2.5, or let's store the variance in a variable store called where. So where has value 2.5, and so these are some basic. Similarly, so if you have the variance of a particular series of numbers, then you can find out the standard deviation also by using the square root function, that is sqrt of variance. So sqrt function calculate the square root of the variable that is passed, and it's the same as that one, and it's just basically to show the uh, how to use the function square root. Okay, so this is how you calculate mean, standard deviation, and square root of some values in Matlab. And I guess this is enough for the statistics part. Now let's jump to the functions part, how to make functions in Matlab. So for let's clear the screen first. For clearing the screen, you can type in clc command, and if you want to clear the variables also, you can type in clear all. So it will clear all the variables. Okay, so let's see how to write a function. Go to the files menu, and in new select this function m file. So once you do this, a new window will open. It's the editor window. So before writing the function, you need to keep in mind one thing, that the name of the function here should be the same as the name of the file, otherwise the function won't run in Matlab. So this is very important, you need to keep in mind. The second thing is, you need to define the output arguments, the values which you want to return to the call of function. Through the call of function, you can return multiple values here. It's not the same as C++, where you can just return one value. You can return different values through reference there, but here you can just define what output arguments you want to uh, get, and you need to define the input arguments. You just need to type in the variables, you don't need to specify what kind of variables would they be. And this the basic structure of function is the keyword function, then square brackets. In square brackets you have the output arguments separated by comma, then the name of function. Suppose in this case, let's start with the square root function. We make our sum of square function, the sum of first n natural numbers. You want to square get the sum of squares of first n natural numbers, so we'll type in sum of squares. Okay, and the output argument will be the sum. You can just define any variable name. I will define sum of squares. Okay, and the input argument will be let's say n. The n will be the n being the number of natural numbers, first n natural numbers, that will be passed on. Okay, so this is the, and this end keyword, you need to define this end keyword for the function. This says that the function has ended here. So if in a file you want to define two functions, you can define it there also, but it doesn't matter. So for that you need to define the end keyword. It's very important. This end keyword is also very important for different loops and statements. For example, if you type in an if statement, if x is greater than 2, and do something here, and if you want to end this if statement, you need to type the keyword end. So as soon as you type end, it will automatically align it with the if statement, and when you click on it, it will tell which end is used for which statement. So this end shows that it's for if, and this shows it's for a function. Similarly, for other loops which you have studied in C++ also, that are for loops and while loops, same thing happens. You need to just put in the end keyword before ending the loop. Okay, so for this I'll give you an example in the bisection and Newton-Rhapson method. So let's start. For example, now we have the value of n. uh, so we need to square the first n natural numbers, and then we need to sum it and put it in the sum of square this particular variable. So uh, first we'll initialize the sum of square with suppose 0 value. If n is 0, the default value will be 0, and we'll use the semicolon because we remember that if you don't specify the semicolon, then it will just output it to the console, but we don't want to just print it, so we'll put a semicolon. Then now what we want to do is we'll go from 1 to n, and then subsequently we'll square each value and then add it to the sum of squares. So for that we will use for loop. We'll type for suppose let's take I equal to and for defining a series we'll type the starting value, that is 1, we'll put a colon, and then we'll put a n, that is from 1 to n. It will go to from 1 to n, and since we haven't defined any, you can also explicitly define the step size. Suppose if we want to define the step size 1 and this n, so what it means that it will start from 1, go to 2, go to 3 because the step size is 1, and it will go up to n. You want to add only odd sum squares, then you can just type in 2 here. So what it will do, it will go from 1, now it will go to 3, then it will go to 5. So, and if you want to add the mm, even numbers, squares of even number, then you can start from 2. So now this means 2 4 6, sum of squares of 2 4 6. So we'll take only 1. So for step size 1, you don't need to define it, it's automatically taken as 1. Okay, so now we need to square the value and put it in sum of squares. So we'll type sum of square, the variable name in which we want to store it, equal to the previous value of sum of square plus the I square, that is I to the power 2, and we'll put a semicolon. And to end the for loop, we'll type end keyword, it aligns it himself, and this is how I do it. And just click on this green play button, it will save the file wherever you want to save it. I have already saved it on desktop, so it will ask for changing the directory. You change the directory and click on change directly, and it will run it. So when you run it, you'll get an error. It says that input argument n is undefined. So this is correct, there's no problem because we didn't define the argument. So we'll type sum of squares, and suppose you want to for the first 5 natural numbers you put so we'll get 55. That's correct. That is 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So that is 55. You can explicitly type it also. You can just check it. 1 square plus 2 square plus 3 square plus 4 square plus 5 square. So that this also gives me 55. So this is how you now know how to define a function in Matlab. Since now you know how to write function, we'll see how to write bisection function and Newton-Raphson methods function. So I have already written the code. You can just write it. So here you'll see the function returns two values, the root and the number of guesses, how many times the function guessed to get the final root value, and the name of the function. Then it has the fx as an input variable, the function, which will be given as a vector of the coefficients starting from a0, from the highest power to the lowest power. The low value and the high value specify the lower and upper bound of the interval in which you want to determine the root, and the epsilon value which is stored in EPS, which tells the degree of accuracy that you want to know. Okay, so we'll start by putting the number of guesses equal to 0 because initially there is no guess. Then in bisection function we get take the middle value and then evaluate to get if it's positive or negative. If it's positive, then we'll take the low value as low and high value as this value, this new value. And similarly, if it's negative, we'll take this as the low value and this as the low value and this as the high value. And if it's uh, absolute value is, that means it's very close to less than epsilon, then we'll take that as a root. Okay, so that's what we do in bisection method. So here we'll start by taking the initial guess. The initial guess as the center value between high plus low, that is high plus low by 2. Then here you'll see a new function that says polyval. Now here polyval takes two arguments. The function is basically uh, the coefficients which are stored, which has been passed on as a vector, starting from the coefficient of x to the power n, then x to the power n minus 1, and so on. And this root is the value of x for which you want to calculate the value of fx. So suppose if I have equation x square plus x plus 1, so the fx will be a vector of 1 1 1, and I want to calculate it for x equal to 1, then this root value will be 1. So this says while, the while is while loop, the same as C++, which I studied in first year. It says that if this absolute means the mod value of this function evaluated at the root point is greater than or equal to epsilon, that means the desired accuracy hasn't reached, will increase the number of guesses by 1. Okay, increase plus 1 because it will again guess. And the same thing, if its value is less than 0, then low will be equal to the root value and high will remain the same, so we don't need to explicitly update it. And otherwise the high value will be taken as root and the low value will remain at low. And this end is the end of this if statement. It specify for the if, and this end specify the end of while loop. And once we have gathered these low and high values, we'll again calculate root as high plus low by 2, and this whole loop will keep on repeating again and again until this evaluation is less than the epsilon value, that is our desired accuracy. And in the end we'll print the value. This, for printing the values in console, you use fprintf command, and this is a placeholder. This means that the percentage sign means that a value has to be replaced here in this string. Point 2 means suppose you want to print only 2 decimal places, so you'll type after decimal, you'll type you want 2 decimals or 2 digits, so you'll type 0.2, and this f states that it's a floating variable. If you want to specify an integer value, then you'll replace this whole thing with d. So since it's very unlikely that it'll be an integer, so we'll type in 0.2 here, and this whole thing will be replaced by this thing, the root value, whatever root value will be there, and these two things will be separated by a comma, and then we'll put a semicolon there, and this end represents the end of the function here. Okay, so let's get started. I will click on this play button. It will ask you to change the directory. You just click on change directory, and now you'll see an error because we didn't specify the arguments. So if you want to get any help on the functions which I have just shown you, you can just go to the help and click on function browser. It will take some time to load, and you need to type in the function name. Suppose you want to get details of polyval, type it, and once you get it, you just click on it. You'll get uh, details of the function. So here you can see that there are two values, the p vector and the x value, and the p vector contains the coefficients in decreasing order. Okay, so This is the details, so you can just see that. Now we'll get the values and we'll store it in variable, suppose root only, and comma. So to store two different variables, you'll use that vector thing, vector brackets, put root comma num guesses. So whatever values will be returned, the first value that is returned will be stored in this, and the second will be in num guesses. We'll put bisection, and then the function arguments. First one is the function in a vector form. So for a vector form, you'll use square brackets. Then in square brackets, suppose I want to calculate for the root for x square minus 5x plus 6. So the x square coefficient is 1, so we'll type 1. For x coefficient is minus 5, so we'll type minus 5, and the constant value is 6, so we'll type 6. So this whole thing represents the function x square minus 5x plus 6. Then we'll pass in the low value. Since we know that this function has root 2 and 3, suppose let's take between we want between 1 to 3, so or 1.5 to 2.5, so we'll take low as 1.5, the high value as 2.5, and then the epsilon. So if we want up to 2 decimal places, we'll type 0.01. So if we want to up to 3 decimal places, you can type 0.001. The only difference would be the number of guesses would increase. So suppose let's say if we want up to 1 decimal place, we'll 2 decimal place, we'll type 0.01, and we'll just press enter. So I incorrectly typed in the name of function. Okay, so one thing happened here, number of guesses was 0. Why? Because in the first case itself, 1.5, the average of 1.5 and 2.5 was 2, and when they put it in, they got less than epsilon, so there was no iteration here, so it didn't guessed any new thing. So so we have to edit this. You can just suppose if I take 1.7 here and 2.9 here, suppose. Now in this case it will take some time to run. It's taking too much time, it shouldn't take this. That means basically it's oscillating between different values. So to stop this, you have to press the control button, and along with it you press C. So the operation has been terminated. That may be because for getting that accuracy of 0.01, it takes a whole lot of iterations. So if we decrease it to 0.1 and press it, we'll get it very soon. So it's 2.89 is close to the root. So it's basically and it took 6 number of guesses. So it went to the 3 side of the root. So it depends on the high and low value on which side this particular root will go. So I was saying that this high and low value, it depends on these values that on which side the root will converge, because in this case the root, we had both 2 and 3 roots, so it converged more towards the 2.9 thing. Okay, so you need to keep this in mind. You can test other functions also, and now we'll see how to write a Newton-Rhapson method. I have already written it. So here the two arguments that will be returned will be x or the root of the function, and the number of guesses. Okay, and the name of function is NRM. Now here you don't need a low or high value, just need to pass in the initial guess, that is x naught, the function in the form of a vector, and the epsilon value as the same as earlier. So we'll start by defining the number of guesses equal to 0, and now so this df defines the derivative of function. and for that we have an inbuilt function called polyder. Okay, so if you want to see the help, you can just type in polyder, and this finds the polynomial derivative. This calculates the polynomial derivative and it will return the coefficients. You can see the help. So we'll type in the function, because in Newton-Raphson you need f dash x also. So this df would be f dash x, and this this x will start with the initial guess x naught. This x will be the root. We'll take it as initial x naught, the initial guess, and the same while loop. That absolute value of this function at x remains, if it's greater than or equal to epsilon, then we'll increment the number of guesses. Then in the formula we have xn equal to xn minus 1 minus the value of function at x naught and the value of derivative at x naught, that is xn equal to xn minus 1 minus fx upon f dash x. Okay, and the next initial guess will take it as this new x, that is this xn minus 1 will be equal to this new xn equal to xn minus 1, and this loop ends here. And similarly this same printf statement which we used in the previous function, that is and now we can just run this, and when you run this you get a sound, that means it's an error. You haven't defined the arguments. So we'll store the values in x comma num guesses. We have already defined num guesses earlier, it doesn't matter, this will store the new values equal to nrm, the Newton-Raphson method. We'll use the same function which we used before, for example 1 minus 5 comma 6. The initial guess, suppose now we want near to root, so 1.5, let's take 1.5, and the degree of desired accuracy is supposed to take 1.1. So it says 1.99, it has gone to 1.99, the exact value is this one. You want to get the full decimal value, you can just go to the workspace and double click this, and it shows you the actual value. It's 1.9, it shows up to 16 decimal places. Okay, so one thing you'll notice here, it's converging much faster. It took 6 number of guesses for the bisection method, although it was a little bit different. Okay, so let's see if it's closer to 2.9. If we take 2.5, it's midway between, let's take 2.6, and press enter. It takes 3, it took to 3.04, and the number of guesses it took only 3. Okay, so here you can judge that the Newton-Raphson methods converge much faster than the bisection method. So one more thing, that in these two methods we have only used the polynomial function. That's basically because they are in Newton-Raphson method, this Matlab 2008 version doesn't support the derivatives of complex function, and to define them symbolically, that is available from versions after 2013. So if you have those versions, you can find roots of complex function. The only thing you need to change here is this fx. You can type symbols in Matlab 2013 and onwards, but it's not available in the previous versions. So this is that's why we have seen only polynomial functions. So that's it for the functions part. And now the only thing remaining is the regression. So we'll only see how you can calculate it using the um, curve fitting toolbox. So we'll see, click on start, go to the toolboxes, and here we'll find the curve fitting toolbox. So before we start, we need some data for fitting the tool. So let's clear the screen. So one thing is that is available in Matlab, there are some lot of uh, inbuilt data sets that you can use for testing your regression functions, regression techniques. One such data set is census, that gives the population at different date of US. So as soon as you load it, you find two variables, the pop and the seed date. The seed date will give you uh, the year, and the pop will give you the population at that particular seed date. So let's go ahead and just plot it. For plotting this data, you need the plot function. The things you need to pass is first the x value, that is seed rate, then the y values, that it pop, and then some formatting options. So if you want to give a color to your if your plot, you need to type in the color code. For example, for blue you type B, you can type G for green, you can type R for red. The default is red. So let's say if we take blue, and since these are discrete points, the plot will be a scatter plot. And for scatter plot you can use any symbol. So if you want to plot it using O, you type O here. If you want to plot it using X, you can type X here. If you want to plot it using plus, you can type plus here. So let's take small o. Whatever you type it, the characters will be shown there. You can just type in, when you click enter, you'll get this plot. So the first intuition which you get it from this plot is basically this must be a quadratic equation that must be fitting this data, or a cubic equation. Generally population growth is you can guess that cubic is maybe very big, so you can fit a square. So but before that let's add some title and some labels to this. For doing this, for typing the x label, or the on the x-axis you will type x label command, and inside you will pass the string which has to be printed there. So if we type date and press enter. Oh sorry, I put in double inverted commas. You have to use single inverted comma for passing the strings. And when I click enter, you'll see the plot that it has now this date caption. And similarly for y label, you'll type y label and pass in the string as population in million, and now you get a population in million. That's too much value. And then for title, you'll type title and pass in the string population versus time, and now you have the title also here. Population versus time. Okay, so now we want to fit our curve to this particular data set. So we'll go to start menu, we'll see toolbox, go to toolbox, and you have a curve fitting tool. You just click on this tool. It will take some time to load. Now you have several options here. First thing is you need to put in the data. So go to this data, click on this button. Now for X data you have seeded all the variables which has been stored in the workspace will be available here. So if you want to put manual data, first need to create those variables, and then those will be available here. So for X data we have seeded, and then for Y data we have the population. We don't need to put in some weights, just and you can also give a dataset name. We'll take the default one, and let's create the dataset. Just click on dataset and click close. Okay, now you have created the dataset. It will be plotted automatically here, and you'll see the title here or the name of dataset. Then you'll go to fitting. You click on fitting and you'll get this thing. So if you want to get a linear fit, click on this new fit, give a name for this fit, suppose I'll type linear. Then dataset, whatever datasets you have created, since we have only this one dataset, we'll take this one, and we'll type of it, we'll take a polynomial. So, and now in this section you have several options. You can fit a polynomial from degree 1 up to degree 9 here in version 2008 of Matlab. So we'll suppose we want only linear regression, we'll click on linear polynomial and we'll click on apply. So it will compute the fit, it will take some time, and it will show the results here, the linear plot which has been plotted. Other things which are available here are the linear model variables. So the linear model which was fixed was p1x plus p2, the function here. Then the confidence interval, 95% confidence interval for the p1 values and the p2 values. Generally we don't calculate in linear regression, those are for interval estimation of means and proportions, but in this case also and it has provided the actual uh, the value of actual intercept and the actual slope would somewhere lie in between somewhere here for 95% confidence. And we have the sum of squared errors. Similarly, we have the r square value, it's 0.921. That means you can describe 92.1% variance of this particular data set, and this is a very good fit. And the adjusted r square value and the root mean square error. Similarly, we got the intuition that it should be a quadratic polynomial, so we can select a quadratic polynomial and click apply, and it will again compute it, and now it looks like much cleaner. It looks much cleaner, and here you'll see different parameters. Um, Even the p1 values, the confidence interval is small. That means margin of error is very less for the slope and this coefficient of this x square and p2 and p3. You can get all the three values here, and for goodness of it, you have SSE, which was much higher, some 2200 here, it's just 159, and the r square value and the adjusted r square values are very high. It's 0.9986 here and 0.9987. So that's a really good fit. You generally won't find this kind of fit. Maybe this is generally because we have very less number of points here, and the root mean square error is also very less. So this is how you fit a linear regression. You can find the parameters of linear and quadratic regression, not quadratic regression, for fitting. And you can just click close. You have other things for analysis. You can go to analysis part. You can predict for different values at 95% confidence interval and evaluate fit at xi. For new observations, if you want to estimate for new observations, and you can just plot the results and plot the data set, and when you click apply to see the results, you'll find this thing. So what else it tells is that this dotted line represents the confidence interval, 95% prediction bound. So this basically means if you have a new value of c date, then the population value will lie 95% of the time will lie in between these two dotted lines, and 5% of the time it won't, because the definition of 95% confidence interval says that if you draw random samples of the same size from the actual population, and when you get the confidence interval estimate, then 95% of the time the mean would lie in this particular interval, and 5% of the time it won't. So you can get the values here also. this is so hard. That's all folks for doing regression. I won't go to the programming part of the curve fitting or the regression function, but if you want to learn those, you can just if you want to save the curve also, you can just click no. So if you want to do it programmatically, you can just go to help, click on function browser. There's a function called regress, and this take in several arguments, and you can get the y's and x values, and it gives a lot of different values. For example, in first case it will give the coefficient estimates, and in this with the interval estimate. In this the residuals are the actual value minus the predicted values, and you can use these things. I'll give you a second. Suppose I'll type regress and type y is the pop values and x values are seeded. You'll get answer as 0.446. That is the coefficient. Okay, so you can just check this function out, and if you have any, thank you very much for listening to me. If you have any queries, you can just post it on Facebook in the comments, and along with the time of this uh, video, at what time you have the problem, and I'll reply to those queries as soon as possible. So thank you very much. Hope you enjoyed this video, and see you soon.